Coach Holmes here, and today we're going to be talking about circumcenter and incenter of a triangle. Now, as far as what circumcenter and incenters are, they're basically unique points given that is the intersection between either perpendicular bisectors or angle bisectors. Now, circumcenter is going to be coming from perpendicular bisector, while incenter is going to be coming from angle bisector. But first, let's look at some of the definitions that we have. First off, one definition that we have is concurrent, which is the intersection of three lines. So that means if I have three lines here, then I have a common point at the intersection here. So that basically means that when I have three lines that intersect, they have a common point right here. All three lines are going to have a common point. That's a concurrent. Now, the point of concurrency is the point of intersection. Of concurrent lines. Let me rewrite that. Okay. So the point of concurrency is the actual point of concurrent lines. So basically, it's literally this point right here that is the point of concurrency. Okay, that's the actual point. Now, circumcenter, like I said before, is the point of concurrency of perpendicular bisector of a triangle. Okay, so basically, if I have three perpendicular bisectors on each side, it actually has a common point, and that point is going to be called the circumcenter. Now, the incenter is a little bit different. That is the point of concurrency of angle bisector of a triangle. Okay, so this time, instead of having perpendicular bisector, I have three angle bisectors, and they have a common point as well. That's called the incenter. Now, what makes both of them unique is that they're going to be equal distance from one another. So, for example, for a circumcenter theorem, the circumcenter of a triangle is equal distance from the vertices of the triangle. So basically, here's what's basically going on. So in the blue, let me make it green. So the green here is my perpendicular bisector, and I have all three at this point right here. Now, what's so unique about it? If I go from the circumcenter to the vertices, they're going to be equal distance from each other. Okay, so they're going to have the same distance from the vertices to the circumcenter. So the lengths are basically congruent. That's what's unique about circumcenter. Now, incenter is going to be the same thing, but the only difference is that from the incenter to the side, they're going to be equal distance. So this right here is an example of incenter. Okay? So we've got to remember that the incenter is not the distance from the incenter to the angle or the vertices, but from the sides or to the sides. Okay? So these three lengths, and I'm coloring it red, are equal distance. Now, if I want to find ND right here, I gotta take this into effect. NE equals to 6N plus 1. NF equals to 4X plus 15. Now remember, since they're equal distance to each other, I can set them equal to each other. And then I just solve for X. So I subtract 1 from both sides. 6X equals 4X plus 14, my fault. Now I got to subtract 4X. 2X equals 14. Then I got to divide by 2. X equals 7. So the distance is not necessarily 7 because we just solved for X. But remember, I can replace X with any of these variables. But I want to use 6X plus 1. Since it's a little bit easier to add. Since I'm just adding 1 to it. So I'll replace the X with 7. 6 times 7 is 42. Add 1 to that. And I get a distance of 43. Okay? So I will have to be able to find distance from the incenter to the side. So I will have to be able to find that. Now we may have to find the distance from the from the circumcenter to the vertices, but again, they're going to be equal distance from each other. So even if I have this type of expression, I just set them equal to each other. So it wouldn't be any difference between the two. There wouldn't be. Now, this time, I'm going to have to find the point of the circumcenter. So I have these points here, so I want to label them. So 0, 3, 1, 2, 3, negative 0, negative 1, and 6, negative 1. 1, 2, 3, 4, 5, 6. Okay. Now, notice I do have, so what it looks like a right triangle, but what I gotta make sure of is that, remember, I gotta be able to find perpendicular bisector. Which means I gotta find the midpoint of the segment, as well as perpendicular slope. Because remember, perpendicular means it makes in right angles, and bisector means in half. So I gotta find the midpoint. Well, let's look at this for example. So this is A, B, C. So really what I could do is that I just need at least 2 lines. I don't necessarily have to have 3, I just need 2 because I know whatever that intersection is, the third line is going to intersect as well. So we can do that just to be safe. I'll make the third line, but I'm going to worry about 2. So I got to find the midpoint between A and B. So that means I'm doing 0 plus 0 over 2, because those are my x values, comma, 3 minus 1 over 2, That gives me 0 over 2, 2 over 2, 0, 1. So 0, 1 is my midpoint between A and B. So I do want to find the midpoint of each segment. But again, I can just do focus on 2. Now, what's perpendicular to a vertical line? Simple, a horizontal line. So I'm going to make the perpendicular bisector blue. Now, I don't know where this point of intersection could be, so I'm just going to extend the line. I'm going to extend the line just in case. Now, I do got to find the midpoint between BC. So I'm going to have 0 plus 6, because those are both my x values, over 2. And my y values are -1 plus -1 over 2. Well, because I got a plus and a negative, those cancel out to be negative. Negative, hold on. Yeah, that's right. My fault. I had to think about it a little bit. I was thinking it was going to cancel out. But -1, now, let me start over. Now, 0 plus 6 gives me 6 over 2. -1 minus 1 is -2 over 2. And that comes out to be 3, -1. So I'm going to do 3, -1. 1, 2, 3, 1. Now, what's perpendicular to a horizontal line? A vertical line. And I got my intersection right here. So my point is at 1, 2, 3, 1. So the point of my circumcenter happens to be at 3, 1. And I can draw the arrows real quick. So this is the point that I'm looking for, and I'm going to shade this in green. So that's the point of my circumcenter. So remember, if we're looking for the circumcenter on a graph, what we gotta remember is that we can just do 2 lines and go from there. Okay? But we do gotta keep in mind about midpoint and perpendicular slope. We gotta be able to find both of them to help us extend the line, so that way we can find the point of circumcenter. Thank you and have a good day.